I've had a long history at Oxford Nanopore. I used to work on the kind of things that these guys have been talking about for the last half an hour or so, but now I've changed focus to delivering bioinformatics for Oxford Nanopore customers. So how do we take all of the things that our algorithms guys develop, and how do we package those up and get them to customers, and particularly non-traditional bioinformatics type people. So the idea about what my group is trying to do is make it simple for anyone to run bioinformatics. We want to break this idea that you have a lab scientist that runs things in the lab and then have a bioinformatician handle the data. We want to make that one thing, make bioinformatics accessible to, and I've slightly reworded the company's kind of phrasing here and put by anyone last, because that's really what I'm focused on. How do we allow anyone to do bioinformatics? So over the last 3 years, I kind of formed this group to do this at Nanopore. Previous to this, we had kind of our bioinformatics coming from left, right, and centre. We had Tim Massingham and I in research putting out base callers and consensus algorithms. We had people like Sean McKenzie, whose name's just been mentioned, doing bioinformatics from the applications group, but we didn't really have a central focus for where our bioinformatics was coming from. So the group I've kind of started in the last 3 years, the customer workflows group, has kind of now acting as a focal point for all of our bioinformatics. So I'm just going to go through where we are, what we've done in the last 3 years or so, and this idea of making bioinformatics more approachable. So there's a quick video here. This is something we presented at NCM for the first time, which is really just a UI on top of Nextflow. So the idea of trying to get bioinformatics accessible to people that don't want to run on a command line, people that have never heard of Linux or what a command line is. But as I say, this is really just a UI on top of Nextflow, and you can kind of see some dirty logs there from Nextflow. That's just what happens if you were to be running this in the terminal. But the idea here is to get from running those workflows into results of the workflows in one seamless experience. So we don't want people to run something in a terminal, then go to a web browser. It's all in one place, so you can run your informatics that everyone at ONT has developed and outside academics, and you can get to data. So here, eventually, we've gone from setting up some calculations to viewing alignments here. This is JBrowse from UCSD. I can't remember where JBrowse comes from. Sorry about that. So this works on primarily one thing outside of bioinformatics. No one uses Linux, right? It's unheard of, right? People use Windows. That's kind of the thing. That's the OS of choice for everyone outside of science. So a big customer base for ours is using Windows. So to get this stuff running on Windows is a challenge. We're focusing on the desktop experience here as well at the moment, so not running in the cloud or a local cluster. So one of the great things about Nextflow, as I'll kind of go into later, is it will use any resource that you want to use. This product is currently fully supported both directly by my group and also our TS colleagues. So how do we go about creating and deploying these things? Well, the first thing we did was to create a library of workflows which are all open source on GitHub. They're freely available. We don't put any barriers to that. It's all permissively licensed. You do what you like with it. If you take those and don't use any of our UIs or other experiences, go for it. We don't really care. It's all written in Nextflow. It's all fairly standardized. We deliver all the software through containers. We make heavy use of Conda underneath that so we're not compiling everything from scratch. And where are we going? There we go. And all of these things come with demo data sets. And most of these workflows also produce kind of QC stuff as well as their primary output. So you don't need to run a QC workflow and then run an assembly or variant calling workflow. You just run the variant calling workflow. You'll get QC data out of that as well. And as I said, these are all freely available on GitHub. You do what you like with them. They're all continuously tested. So a big part of what we've done, as well as standardizing everything, is we put a lot of work into continuous integration. So whenever one of my guys makes a commit to a project, this code is tested across Linux, Mac, and Windows. You'll see I've cheekily written WSL. For those in the know, this is not really running on Windows in the true sense of the word. We do want to get to the point where we start compiling a lot of stuff natively for Windows. Sadly, a lot of bioinformatics code is kind of makes use of POSIX APIs that just don't exist on Windows, so you can't really do that. So how do we get here? We standardize, as I say, we standardize around Nextflow. Why do we choose Nextflow? And really, when we started, there was only two real choices as a workflow manager, SnakeMake or Nextflow. We needed something that worked on a wide variety of platforms. So, as I say, the desktop experience is useful. It fits with the MinI kind of sequencing anywhere, anyone. Clive mentioned low resource countries. One of the things that is now becoming possible in those territories is to, at least you have a stable internet connection. You can get data to the cloud if you need to. We need to be able to deploy this to everyone, so we need to use technologies like Git, Docker. If you don't know, this last one here is an Electron. That's how we make UIs. And everything needs to be documented. But there's a key point here, and that's the last one here, real time. Right? Workflow managers in bioinformatics do not typically work in real time. Everything is centered around, you've got your data, you want to process it in a batch to get a result. Nextflow is a bit different. It can, and I'll go into an example of this, it can process data in real time. It can see files appearing on your file system and process them as they appear. Now, for a lot of things, assembly, you're not going to do assembly in real time. You need all of the data there. I did demo something 8 years ago at London Calling, where I was trying to do assembly in real time. It kind of works. You need to get some data, but I would stick to doing those things in real time. But there are things we can do in real time. I'll come back to an example of that. Now, when we started, there was a bit of a conflict in my group. Nextflow has a bit of a reputation for being hard to learn, and I'll try to convince you now that that's not necessarily the case. So. The guys at Sakira who developed Nextflow are here. They're going to hate me for this because I've used this quote more than once now. Like, it's not hard to learn, but there's always this sinking feeling that you're doing something not quite right. And that feeling never completely goes away. And that's true in my group now. We still don't know when we write some code, if we're writing Nextflow code, that's the way it's supposed to be done. We've got some experience now. We know kind of how some of our younger colleagues, we kind of show them, don't do it like this, it makes it much easier. But there's reasons for this. Primarily, it's written only by one person. It's kind of grown organically. The last point here, there's kind of a lack of true expert knowledge in the community about how to use Nextflow for some things, but there are kind of community guidelines and standards. I've written a more kind of extensive blog post on this as well, so you can go read that. But it's not all bad. It's not different. It's not hard. It's just different. Things like SnakeMake are very pattern-matched orientated. You stitch things together implicitly by matching file names, whereas Nextflow is much more, as I say here, like writing code. It's you chain things together by calling functions. So that kind of makes it easier. It's just different. It's not hard. Again, I'll come back to why we want to use this. It's this real-time functionality. And well, I'm not going to mention his name, but there's somebody in my group that still doesn't like Nextflow. And he would like us to rewrite our own workflow manager, but we're not going to do that because we want you guys to engage with us and create workflows, and I understand that no one is going to use a workflow manager that we make. Right? There's standards for doing this, and if we try to make something better, we're going to fail. So that's why I've got this Shakespeare quote there. So real time, I promised I'd get to this. So metagenomic sequence is a very quick example, really. So you take a sample from a lake, water, whatever, and you want to know all the species that are there. And as you go through a sequencing experiment, you will collect more data through time, and eventually you will saturate how many taxa you've observed, maybe in sample 1 here. But in another sample, you might see that this curve doesn't plateau, it will keep going. So there's this long tail of low abundance things that will keep going. And you can see in this case, for sample one, you could stop sequencing halfway through this time. There's no point carrying on, but you don't know that ahead of time, of course. But this can be done in Nextflow by using this channel.watch path. So that's how you watch for inputs coming. You can combine this with adaptive sampling as well. So you could change these profiles of these curves to sample more quickly everything that's in to measure everything that's more present in your sample. I'm going to go through this because I'm kind of out of time, but the way that we develop these things, we always come from the point of what is the biology that people want to do, what is the user experience that they want to create, or we want to create for them, and obviously that leads to code. We don't try to develop anything up front, so anyone knows about this idea of extreme programming. You embrace change, you make sure everything's tested, you can make changes on the fly. If something breaks, you know it's going to break before you release it. As I said at the start, we kind of automatically test all of these on every commit. And we embrace feedback from users, both internal users and external customers. That's why everything is freely available on GitHub. It makes people come to us directly rather than going through our kind of TS people. One last thing, I said we made heavy use of Conda. One thing that we are doing that we've kind of kept secret, but we are mirroring all of BioConda and trying to compile things for ARM. Anyone that buys a Mac these days is buying an ARM device, not an Intel device. So Rosetta 2 is quite good for running x86 code, but it will just kind of fail and break silently. So we're trying to rebuild most of BioConda, or at least the parts that we use for ARM. We also want people to run their own workflows in this UI, so we've kind of enabled that. This video will show you doing that. This is importing a workflow that's not ours into the system, and then you'll be able to run it, and you see it there. I just chose one there that's from NF Core that does Nanopore analysis. Where are we going? The one thing that Clive mentioned last night is we are now extending this to the cloud, so through the same UI. This video looks no different. There's one crucial part, which is as it goes through, one button gets ticked, and then things will be running in the cloud. But otherwise, we're trying to create the same seamless experience here. So all the data starts on your device, compute will be done in the cloud, and then you get your results back. We're announcing, I guess now, that we're going to have an early access for this. If you want to go to this link here, we will. This is going to be quite risky, but we will make this available for free, and you'll be able to run any analysis that you wish on this. Someone's going to hate me for this, because it could get quite expensive quite quickly. But in the early access, at least, we will endeavor to allow you to run any analysis that you wish on that platform, and engage with us and try to break it before we release it fully. And I think that's me.